Hey guys, welcome to another video. This video is about stereoisomers, so chiral centers, and identifying what and how to find. Hey guys, welcome to another video. This video is going to be about chiral centers and how to identify them, and also doing R versus S configurations. So let's get started. So what is a stereocenter? Remember, stereocenter is the same thing as calling something a chiral center. It is a carbon attached to 4 different groups. So that's very important. So you won't see a stereocenter that has a CH3 group that's attached to something else because it has, 3 hydrogens that are all the same. You want a carbon that's attached to X, Y, R, and A. 4 different things that it's attached to. Okay, so in this following compound, this question asks that there is one stereocenter, and it asks us to find it. Let's go through all the carbons and see if there's one that has 4 distinct different groups attached to it. Let's start with this carbon. This carbon would have 3 hydrogens, so it's not going to be that because those hydrogens are the same. This carbon has a CH3 group attached to it, and it has this hydrocarbon chain with that alcohol going up. So those 2 are different, but it also has 2 hydrogens right here, so it can't be that carbon. And we have another CH3 group right here. So process of elimination, our only possible option is this carbon. And let's check to see if that's true. This carbon is attached to an alcohol group, so that's different. It's attached to a methyl group, and it's attached to an ethyl group, and then it has a hydrogen going out. So we identified that. That is our chiral center, our stereocenter. Okay. Going through some more practice problems on that. Let's try this next one. Remember, CH3 groups on the end of these hydrocarbon chains can never be chiral centers because there's 3 hydrogens attached to them. Neither can these 3 because those are CH2 groups that attach to different things, but it still has 2 hydrogens. But this one right here has a methyl group, it has an ethyl group, it has a propyl group, and it has a hydrogen. So 4 distinct groups on that carbon, and that is our stereocenter. Let's put out these CH3 groups, and our CH2 group can go. And now we have to think about if this one, does this question ask, below there's one stereocenter. So there's only supposed to be one stereocenter, and it's between these 2 compounds. What do you guys think? Well, I would say this one looks better than this one because if we're counting carbons, they look the same, but let's just go through them both at a time. So this one is attached to a methyl group, it's attached to an ethyl group, and it's attached to an isopropyl, and it has 1 hydrogen. This is attached to a methyl and a methyl. So those 2 methyls are the same. So that wouldn't be a chiral center. Our chiral center would be this one right here. That carbon, because we've got 2 methyl groups on that other carbon. All right, this one right here, we can rule out all of these because those are all CH2 groups. This one is definitely could be a possibility. This one could be a possibility as well, and we can rule out this one. Now, we have to figure out this one first. Is that a chiral center? I would say no, because you have, if we're counting carbons, you have 1 carbon, 2 carbons, and then 3 carbons. And on this other side, you have 1 carbon, 2 carbon, 3 carbon. So that is an identical pathway, you could say. So that is not a chiral center. Let's see if this one is. We have an alcohol group on top, we have a methyl group down below, and we have a branching out ring right there, and we have 1 hydrogen. So that's 4 distinct groups. So that will be the chiral center or stereocenter. All right. Hopefully that makes sense. With these chiral centers, you can order them by, highest priority, lowest priority. So if I want to do a simple example right here, this would be a chiral center. We have a methyl group, we have an alcohol group, and we have an ethyl group, and we have a hydrogen that I will also draw. As it says right here, you have to find the stereocenter. You have to label each group of the stereocenter 1 through 4 based on atomic number or atomic mass. So if I want to go back to this example, this alcohol group will be number 1. It is that alcohol group's electronegative, that oxygen is electronegative, so it's going to be number 1. This hydrogen is going to be number 4 because it only has an atomic weight of 1 or 1.01. So that's going to be 4. This ethyl group will be 2. So I'll label that 2 because it has more atomic mass and it's bigger than this methyl group. So we'll label that 3. So we labeled them. Really, you should show the, and for these practice problems, they'll show a wedge and a dash. And you want your highest priority, that number 1, to be on a wedge, and you want your lowest priority, which will more than likely be a hydrogen, as a dash. So now it asks us to determine if numbering goes in clockwise or counterclockwise direction. So it looks like, going from 1, 2, 3, 4, it goes 1, 2, 3. And then that's 4. Remember, with these wedges and dashes, you can mix them around. So you can show this as this as well, and it means the same exact thing. So if I want to renumber this right here, we would have the same thing going on. So we determine if it's clockwise or counterclockwise. That would be clockwise, right? That's clockwise. And it says if the 4th priority isn't on a dash, change the numbering so it does, thus changing the R versus S. Well, I didn't add that. Clockwise is an R configuration and counterclockwise is an S configuration. So for this example, this would be an R stereocenter or chiral center. So we would label that R. And this is really important for a lot of things, but one thing in particular is the nomenclature. And you can add that R into your nomenclature. So we did that. This part is really important right here, this 4th step, that if your 4th priority is not on a dash, you really have to change that numbering around, and you have to search around whatever's connected to it. And that also changed the R versus S. And we'll get into a few examples on that. And remember, clockwise R, counterclockwise S. All right, so let's try this problem. I think I just did this problem, but it's good to go over it again. So our alcohol group would be number 1, right? We have a very electronegative thing in alcohol, and that will pretty much always be your first priority. And then we have our 4th priority, this hydrogen as the lowest mass. We have our 2nd priority over here and our 3rd priority right there. This looks like we have a 4th priority that's on a dash, so we don't have to switch around any numbering or anything. We can just look at this raw, and it looks like it goes counterclockwise. Right, we went from 1, 2, and 3 in a counterclockwise direction. So this would be an S configuration, and you usually write that S right by the chiral center, so you know what you're talking about. And if you have multiple chiral centers, it's easy to depict what configuration it is when you're looking at it. So that would be an S because it's counterclockwise. Let's try this. It asks us, the compound below has 1 stereocenter. Find it and determine whether it is R versus S. This question could throw you off because we have this going on right here. and it has a wedge and a dash. So you might be tempted to think that that is a chiral center, but you got to remember the definition of a chiral center: 4 distinct groups attached to a carbon. We have 2 chlorines on this carbon, so that cannot be a chiral center. So don't be tricked by that. So this would be our chiral center, right? We have an alcohol group. We have a hydrogen group that is a wedge, because again, if we have a dash shown, then we probably, if nothing else is shown, we have a wedge. So we have a hydrogen right there. We have this group going on, which is different than this group. So we have a chiral center right here. Let's assign priority. So directly attached to this carbon is an oxygen, so that's going to be priority number 1. Directly attached to this is a carbon with stuff going on, I guess you could say. And this is really important to figure out. Obviously that's 1, this is 4, but trying to differentiate this 2 versus 3 and which one is more important, you have to look at what this carbon is attached to. So let's start with this one. That carbon is a carbon with no hydrogens. So it's a carbon that has attached to another carbon, which is a double bond, another carbon and 1 more carbon. So that has all carbons. This one is a carbon attached to, let's see, we got an ethyl group, we got 2 chlorines, and let's see, another carbon. So which one is going to be, which one do you guys think is going to be more or better, I guess you could say, for priority? Which one would be the higher priority? I would say this one would be higher priority because you have those halogens, which are very electronegative, and that would be the higher priority than that aromatic benzene ring. So let me clear things up here. So this would be 2, because we have 1, 2, and then this would be 3. And then we have our hydrogen as 4. Now, one thing to note here, again, this would go in a clockwise direction, but since our hydrogen is on a wedge and we want it on a dash, so we want it switched around, you have to switch around the R versus S. So this would go in an R direction, but since we have to switch it around, it is now S. So what I did when I was, going through this class to show that in real time, let me just rewrite this. So this is a hydrogen. This is 2, 3, 4, and 1. I would go, oh, it's going this way, cross it out, and it's going this way. So because you have to switch around these 2 groups, because we want that 4th priority on a dash, you have to switch around the configuration. So the final answer of this is that it is an S configuration. Okay, we have this next one right here. Let's determine where the stereo center is. It looks like this one is a good priority. We have a wedge sticking out, and these 2 groups are different right here, and we have a hydrogen that's not shown, but I'll write it in, and that hydrogen would be a wedge. So again, this is a CH3 group, that's a hydrogen, and we can just label that hydrogen our 4th priority right away. Okay, so this is our stereo center. We can't label this methyl group, even though it's on a wedge. We can't label that our number 1 because we have to, first look at these, because methyl isn't the best, and it's usually not the highest priority. So let's look at these groups going out right here. So this group is a carbon that it's attached to 4 different distinct things, and it has no hydrogens. So that's going to be better than this one right here, because this is just a CH2 group connected, to 2 other carbons. So I would say this is our first priority right here. And then this one, and then that is our third, that methyl is our third priority. Let me just make the coloring better. There we go. So that CH3 group is worse than the CH2 group, and that CH2 group is worse than that carbon with no hydrogens. So we have a pattern going right here, which is counterclockwise, but again, our hydrogen is on a dash, so you have to switch around that configuration. So it's going this way. So that's an R configuration. Hopefully this video helped. My next video will be about mechanisms, so drawing those arrows and everything. Again, R versus S, the biggest part of it is just whether or not you have that fourth priority on a wedge or a dash. And I'm sorry, this is actually an S configuration because that fourth priority is on a dash. So I'm mistaken there. So this is actually an S configuration. I thought it was on a dash for some reason. So we don't have to switch anything around, but if you do encounter a problem like we did right here, all it takes is just remembering that, our fourth priority is on a wedge, is on this wedge right here. And if our fourth priority is on a wedge, we just have to switch whatever configuration it was, we have to switch it to the other one. So that's the only thing here. Hopefully this video helped. I will see you guys in the next one.